A number. All right. So let's start with the just-in-time notes. So just-in-time, the light lavender is not going to work. The just-in-time notes are also the 96 notes, just another way of doing it. All right, so we're going to talk about exponents. So an exponent, so b is a real number and n is some natural number. And so remember, a natural number is 1, 2, 3, 4, doesn't, and so we can call, so b to the n means b times b times b times b times b, right? And here I'm using the obvious multiplication sign of the solid dot. B to the n is called an exponential expression, so we just call these exponentials, where b is called the base and n is the exponent. And notice we have these properties that as long as my a is not equal to 0, I guess I should have just left it as b, right? So anything to the 0 power is 1, right? Except for 0. 0 to the 0 power is undefined, right? We're just going to call that undefined and never not deal with it in this class. A to a negative power is 1 over a to that power. Okay? So we're going to want to simplify a couple of these expressions. So let's go ahead and do it. So 5 squared means 5 times 5. So this is 25. Negative 3 squared is equal to minus 3 times minus 3 times minus 3, which is equal to minus 3 times minus 3 is positive 9. So this would be positive 9 minus 3, which is equal to minus 27. Here, 3 to the negative 2 power, it's the same as 1 over 3 squared, which is the same as 1 over 9. 0 squared is 0 times 0, which is equal to 0. Actually, 0 to any power is 0. 6 squared is defined to be 1. And why do we define it to be 1? So why is anything raised to 0 power to be 1? Well, let's pretend here we've kind of touched on this for a little bit. Let's pretend I had x plus 3. And I said, technically, this is x to the 0 power. Well, what did I mean by that? It means there's a 1 there. It means I have none of them. So if I have no 6s, I have 1. But notice that 1 times any number is equal to that number. And so the reason we define it, and this is the definition, we define it to be 1. That way, it's the multiplicative identity. And what does the multiplicative identity mean? It means the thing I multiply by something to get back what I originally did. The multiplicative identity is 1. The additive identity is 0. Hey. No, they're fine. And is 0. So the identities will take things. They'll take things of itself, things back to itself. So if I multiply by 1, I get back to a. I add 0, I get back to a. So 6 to 0 is defined to be 1 because that's the multiplicative identity. Okay, so it's just a definition. It's always going to equal to 1. So negative 4 to the 4th. Another thing you can do is notice that if this is even, this will be same as 4 to the 4th, right? Because I'll have 4 negative signs. If this is odd, it'd be say we had. Let me do. Woohoo! Didn't I want to do that? Let's just say I have negative 4 to the 3rd, real quick. This will be negative 4 to the 3rd. And so if it's even, if your power is even, when you multiply by a negative, you're going to get a positive back. And if it's odd, you're going to get the negative back. Okay, so notice here we had an odd power, and then we got back negative 27. Here, 4 times 4 is 16, times 4. 16 times 4 is 64. So this would be minus 64. Hold on. And this will be positive 256. Hold on, let me put the little buggers in the box. Hey, Hey, you two. Do you have to completely trash the room while I'm trying to teach? Come here. Come here. Come here, little monsters. You and Dudley. Ugh. You are fine. You are fine. We not completely trash the room for 5 seconds. All right. So let's talk about, does that make sense how to do all those things? Has you guys seen most of this before? Yes or no? I mean, if some of it's new, that's okay. All right, so most of you have seen this before. So I just want to do a quick review because we're going to start moving into stuff with, it's more my speed. Yeah, you two need to calm down for a half second so you don't trash the whole room. We're going to do some more complicated stuff in a second. I just wanted to go over the basics. All right, you two, I'm going to let you down. We're not going to trash the room. There they go. All right. So let's talk about scientific notation. So there is a boo-boo here. This should not have, it should be strictly less than. Okay, so here I have, instead of being scientific notation, if it's some number between 1 and 10, we're up including 1, but not including 10, so it could be 9, whatever. And n is an integer, and so we're going to just write this scientific notation. To do that, I usually draw a little period here. Hi. I draw a little period here, and I go 1, 2, 3, 4. And so here would be 5.6 times 7, 8, 9 times 10 to the 4th. Okay? So go ahead and write in chat what B is and what C is. So go ahead and write that in chat, and then we'll go to the next page. Hey, look what I got. Sure, roll 6 sucks. There we go. Anyone get what either of these two are? B or C? Okay, we got some of them. All right, so here, I want to go, and I'm going to count this way. So it'll be 1, 2, 3, 4, 5, 6. So it'll be 3.4 times 10. Instead of going, if I went to the left, I'm going to make it positive. If I go to the right, I'm going to make it negative. Oops, that does not look like a 10. To the minus 6. How do you know how many places to move the decimal over? Okay, so we want to make it so this is a single digit, right? We wanted a single digit dot something, right? So here, I'm going to move it over 1, 2, 3, 4, 5, 6, and that will give us, it'll be 3 point something. So I want to make it so it's between 1 and 10, but not including 10. Here, I'm going to move this way, so it's 1, 2, 3, 4. So basically, you're going to move the decimal point. Hey, you little monsters! Could you not go full crazy? You're going to move your decimal point until you hit the very first digit, your non-zero digit. And so here we're going to move it to here, right? So I'm going to move it 1, 2, 3, 4, 5, 6. And so this will be 1. But notice here, I need to still keep all these zeros. Here, I'll hold 1 land shark. And so I need to keep all these zeros. Okay, so you just move it until you get to the beginning of the first digit. Okay? Did I take away your friend? You guys going to play nicely now? Okay. And so these are the answers. So let's do another example of B real quick. Let's just say if I had 0.07804. you're just going to move it to the right 1, 2, 3 until you hit your first digit, okay? And so this would be 1, 2, 3, so it'd be 7.804 times 10 to the minus, what is it, 1, 2, 3 to the minus 3, okay? So this is scientific notation. You'll see this in your science classes. The reason we have to keep all these digits because this is how accurate it is. And so we want to keep that level of accuracy. Why wouldn't it be -6? Oh, so this one, yeah, so this one's -6, this one's +6. If you go to if you're moving your decimal point to the left, that makes your number smaller, so you need to have 10 to the higher power. And if you move it to the right, you're making your number bigger, and so you have to have the negative. All right, let's go to our, oops, let me leave this up for 1 second so you guys can copy it down. We'll go to the next one. Oh, it's so tasty. There you go. All right. So let's talk about properties. And here I spent time to write in examples. All right, so here's all your properties for exponents. Okay, so here's all our properties. So if I have a times a to the n times a to the m, I can just add them up. So here it's like 3 to the 4 times 3 to the 7 equals 3 to the 11. And a way of thinking about why that is, let's do it with a slightly smaller version. So 3 squared times 3 to the 4th. Well, this is equal to 3 times 3, and this is equal to 3 times 3 times 3 times 3. And so we're just adding up how many 3's we have. 1, 2, 3, 4, 5, 6. So this would be 3 to the 6. Here for a slightly larger number, we can just add it up and we get 3 to the 11. You two need to go out or something? Hold on. So here, if I'm dividing, I'm going to minus the 2 because here, and this one's actually easy to show. Here, if I have 4 5s up top and 6 5s down below, I can cross off 4 of them. And so here, I'll have 4 5s up top, 6 5s down below. So I have 6 minus 4, so that's 5 to the negative 2, which is 1/25th. And notice that this is also 1/25th. Here, if I have a to the n times m, or raised to the m power, I multiply. Here we'll go ahead and show what that is. So 3 squared is like 3 times 3. And then if I take that to the 4th power, that'll be 3 times 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 3. So that is 1, 2, 3, 4, 5, 6, 7, 8. And so it's just the same, or I have 4 sets of 2. And so that's why we multiply. Here, I can distribute it in. So here, if I have 3 and 5, I can put it into a 4th and a 4th. Here, if I do it over a fraction, you can distribute into the fraction. So it'll be 3/5 to the 7th power. So it's 3 to the 7th power times 5 to the 7th power. And if I have a fraction to a negative power, I can just flip it and multiply it. So here are 3/5 to the negative 7. The 5 goes up on top and the 3 goes down below. Okay? All right. So do me a favor. Go ahead and try to do these real quick, and then I'll be back in 2 minutes and see what you guys have. Okay? Can you go back and explain the 1/25th? Yes. Let me do that before you guys try this. So here I have 5 to the 4th over 5 to the 6th. So I have 4 5s up top and 6 5s down below. Now, algebraically, I can just do it. It'd be 4 minus, here I can have 4 minus 6. So 4 minus 6 is -2. And remember that 5 to a negative number from our first page. I have it somewhere on my first page. Yeah, 5 to a negative number is the same as 1 over that number. So this is equal to 1 over 5 squared, which is 1/25th. Or notice here, if we just calculated it out, we have 4 5s up top, 6 5s on the bottom. 4 5s up top, cancel out the 6 5s down below. And that leaves me 5 times 5, which would be 1/25. Okay. So go ahead and try these two. Oh my goodness, they fell asleep. Okay, so go ahead and try these real quick, and then I'll go through them with you. Eat this. Not eat everything we're not supposed to. You wearing no shoes, Puffles? Come here. What is this? Oh, they're out of water. You guys are just thirsty. Hold on. Hold on. I'll be back. I'll be back. I'll be back. Stay. 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 Pick it up. Pick it up. Here you go. Right. Nope, this side. Nope. Water is here. All right. Did you guys get some answers? Oh, great. All right. So here we have y to the 4th to y to the 8th is equal to, someone has it in here, so it'd be 4 plus 8. And so this is equal y to the 12th. All right, for E, someone has an answer for E, so we'll go ahead and do that. So we have r to the 7th minus 3, following this rule right here. And so this becomes r to the 4th. I notice if I did this out longhand, this would be r times r times r times r times r times r 1, 2, 3, 4, 5, 6, 7 over 1, 2, 3. And that just leaves me 1, 2, 3, 4 up top. All right, for B, someone got, so here we'll have c to the negative 2. So this is really c to the 4th times a negative 2. So c to the 4th times a negative 2 is minus 8. So c to the minus 8. Or you can also write over 1 2 over c to the 8th. That is okay. Here, which ones do we have? We have c is 2 to the 3rd over x to the 3rd. So we just distribute this in. If you wanted to, you can simplify it. Here for D, I don't think anyone got D quite yet. So D, we're just going to distribute into each of these. And so I'll have 3 to the 3rd, a to the 2 times 3, and then b to the 3rd. A to the 3rd is 27. A to the 2 times 3 would be a to the 6th. So everyone see why that's 6? And then this becomes b to the 3rd. Does everyone see why this is 6 right here? I don't even know how you guys got that. Come here. Come here. Look, here's a brand new rope toy. Is this what you want? Let's switch on the rope toy. Look. It's a toy. It's a rope. You know what's great about the rope toy? It doesn't clink around. The puppies want. They slept through the night, so I got like 8 hours of sleep, and I'm thinking, this is amazing. But unfortunately, they haven't slept during class, so I'll have to get up earlier to run them. Okay, does everyone see why this is a to the 6th? Yes, okay. If everyone's good on that, we'll go from here. All right, so this is a big mess. So let's do it one step at a time. So this becomes x squared over y. This becomes, so, and then here we're moving the 3. So this is x cubed. 3 times 3 would be 9. Y to the 9th. Oh, I forgot my y squared down here. And z to the 3rd. So here I have, and so let's go ahead and put this all together. And let's do it one variable at a time. So let's look for where my x is. Well, I have an x up top and an x up top. So x times x squared times x to the 3rd. So x times another one. We'll be using this property. So we're going to add them up. So x plus, so 2 plus 3 would be x to the 5th. Here, I have a y up top and a y down below. So I'll be using this property. Oops, not that. And so here I'll have y to the 9th minus, so y to the 9th over 2, so it'll be 9 minus 2, which gives me y to the 7th up top. And then here I still have a z to the 3rd down below. Okay, so that's how you do that one. So just take them one variable at a time. So I have two x's on top, so I add them up. I have an x, one on top, one below, so I take the top number minus the bottom number. And then z, there's only one z, so that stays the same. So here I distributed it in, and then I just collected my variables. All right, let's talk about radicals. All right, so the square root of a equal to b means that b squared equals to a, where b is greater than 0. Okay, so that's what it means. And then here we can also have this for higher power. So if we take the cubic root, it means what raised to, so cubic root would be 3. So like this is the cubic root, put a little 3 there. Of a equal to b means what? Means b to the 3rd equals a. So that's what we're looking for. All right, so here, when we simplify this, I want to find the square root of 16. What squared is equal to 16? Well, 4 squared is equal to 16, so the square root of 16 is 4. Here, if I take the 4th root, what to the 4th power is equal to 16? Well, 2 to the 4th power is equal to 16. And so here, the quartic root, so 4 or quartic root here would be 2. Here, notice that I can't take a square root of a negative number, but if I take -2 times -2 times -2, which is equal to -2 to the 3rd, well, that's also equal to -8. And so here, I just want to show you that if it's an odd root, you can have a negative and you can take a negative root. And this actually just ends up being -2. So, oops, -2. Okay. All right. So let's just do a couple of these examples together. How to deal with stuff with radicals, and then we will call it a day. And then I'll go take out the little monsters. Hey, do not eat that. All right. They're super rambunctious today. All right, so here, a 9th to a half, remember, something to the half power is equal to the square root. And if I have something to the 3rd power, so if I say I had 27 to the 3rd power, that's equal to the cubic root. So these are equivalent statements. So this becomes 3. Here, if I have this, I can rewrite this as x to the 5th. And so this is the same as the 4th root. Oh, sorry, I forgot to explain what I was doing. Back it up. Back it up. I wrote this section, didn't explain it. So law of radicals. So since So since a to the 1 over n is equal to the square root of the nth root of that, all the exponential laws are the same as the radical laws. So all these laws right here, all these laws apply for the radicals, because you can just convert any radical or square root into a power. And so they have the same properties. And so these are all the same. So notice here, so if I have a to the half, that's the same thing as square root of, or 9 to the half, that's the same thing as square root of 9. Square root of 9 is 3. If I have 27 to the third, that's the same thing as the cubic root of 27, which would be the same thing as 3. Okay, because 3 times 3 times 3 equals 27. Here, if I have x to the fifth, and then I take the fourth root of it, I can rewrite that as x to the fifth to the 1/4 power, and then I can just put that together, and then here I'm just multiplying. So this would be x to the 5/4 power. Once again, for here, if I take the fourth root, I can rewrite that as 81 x to the fourth times z to the eighth times to 1/4 power. Now, if I do that, I can have I'll just rewrite this as the 84th root of the fourth root of 81. Well, a fourth times 4 would just be x, and z to 8 divided by a fourth would be z squared. And then here, the fourth root of 81, well, let's just type that into a calculator. Let's just do that through a calculator. I don't expect you to know how to do that. I do expect you to find it in a calculator, though. All right, so here in the calculator, I'm just going to type in 81. And so anytime I do anything that's a large root, I'm just going to always just type it in as, hold on, a fourth root. There we go. Hi, not what I wanted. That's what I wanted. Okay, and so here, this is how you type it in. It would be 81 caret 1/4, and you put that in parentheses. Notice how Wolfram Alpha automatically knows what to do, and this is a third, or 3, okay? And so our final answer here would be 3xz squared. All right, so let's look at this. Look at this. So here I have 8 to the 2/3 power. Now, can I type that in a calculator and get an answer? Sure. In fact, let's do that first. Let's do that first. You got strangely quiet. They passed out. Okay. The joys of being a new parent. All right, can I have my mouse, please? Thank you. All right, so let's type this in. So if I was going to type this in, I just type 8 caret parentheses 2 divided by 3. And so that gives me 4. Great. So that I know what the answer is, but how did I get there? Well, there's 2 ways to do it. And so let's rewrite this as the cubic root of 8 squared, right? Or let me not do that so fast. We'll have 8 to the 1/3 power squared. So I can split this back up. 8 to the 1/3 power is the same thing as the cubic root of 8. And then I can square it. Well, the cubic root of 8, so what to the third power is 8? And the answer is 2. So I'll have 2 squared, which is equal to 4. So here you can split it out. Here, if I have a 2, I can add this up to be 5 square root 3. So here I can just treat this as a variable. So if I have 2 square root 3 plus 3 square root 3, that's equal to 5 square root 3. Here, if I see something like this, what is it? Well, so here I wanted to do this. So let's think, how can I simplify this? Well, I can simplify this as 2 times 2 times 32. That's 2 times 2 times 2 times 2. Let's not do it that way. I think I'll get you lost that way. here, I'm going to have this as 16 times 2, right? And what I'm going to want to do is try to split it up into perfect squares. And this I can write as 100 times 2. So 16 is a perfect square. And what do I mean by perfect squares? It'd be 1, 4, 9, 16, 25, 36. Gee, I can't remember what 7 times 7 is anymore. 64. 7 times 7. Oh, come on. Function brain. 7 times 7 would be 54. No. What's 7 times? Thank you, guys. My brain was. You ever open up the file cabinet in your brain for something very obvious and you like pull up the file and it's empty? It's like, where's that number? So it'd be 64 and then 81. So here your perfect square is less than 100. Okay. Thank you, guys. And so here, and then we'll have 100. So try to pull out perfect squares. So here I can have 16 times 2 is 100 times 2. Then I can pull out the 16, take the square root, so it'd be 4 square root 2. I can pull out the 100, which becomes 10 square root 2. And then I can add it up to be 14 square root 2. Okay. So this is how you can simplify radical expressions, is you can pull out perfect squares and see if you can get the same. Noticed one real thing, if I have 3 square root 5 plus 2 square root 7, this is as simple as it can get because I cannot add units of square root of 5 to units of square root of 7. Okay. All right. Okay, so I am going to do, I want you guys to try some of these. So I'll actually have you guys try I at the end. Let me kind of go over this. So here, I have minus 3 cubed. Notice minus 3 cubed is not equal to negative 3 cubed. Well, actually, in this case, it is. I lied. So let me be very clear on what's going on. So here, what I'm going to do is it's still going to be negative. Notice I'm not cubing the negative. I'm only cubing 3. So that's 27. And then I take the cubic root. Or the cubic root of negative 27 is minus 3. And so what we see here is that if I put parentheses in here, we could have just canceled this straight away. And we wouldn't have to have done anything because I would have minus 3 to the third raised to the 1/3 power. And that just cancels, right? Because 3 times the third is just negative 3. But since we didn't have those there, that this parenthesis doesn't exist, I had to multiply it by, I had to cube my 3, then negate it, then take the cube root. In this case, since it's odd, it ended up being the same. All right, we're supposed to be done in 3 minutes. So let me just plow through the last 2 real quick. So I just want you to see a whole bunch of examples of these and write them down. So this looks like a mess, but if I rewrite it as this, so all I've done is saying this square root is just x to the 1/2 power, right? I'm going to multiply that by an x, and then I'm going to take all of that and raise it to the 1/2 power. So that's what I have here. Well, this is technically x to the 1st power. So if I put these two together, I have x 1 plus 1/2 is x to the 3/2, right? And I raise that to the 1/2 power. Well, then I'm going to multiply 3/2 times 1/2 will give me x to the 3/4. And so here I've simplified that. Okay. All right. So real quick, what's the answer to I? Let me have you do at least one. Go ahead and do I for me and write the answer into chat. You're going to use 2 different rules here. You're going to use the negative rule to move something down below, and then you can convert it into a cubic. So give it a try, and I'll show you the steps after I have a couple of people try. Just give it a try and put the answers in chat. All right, we got one answer of a third. We got two answers of a third. And those are correct. And since we're almost at time, because of, I mean, let's go over it. So here, I'm going to write 27 to the 1/3 power. And then that's going to be the same thing as 1 over 27 to the 1/3 power. So here, I use the rule for if it's a negative, I can just put it on the bottom. Well, 27 is the same thing as the cubic root of 27. And the cubic root of 27 is, of course, 3. Okay. All right, so the first page of these notes, I assume most of you probably seen before in some way or another, right? The second these properties you probably messed with a little bit, but may have forgotten. And so we went through all those properties. And so once you get familiar with these properties, you'll be better. And then the radical stuff, some of this radical stuff is probably a little bit new, but as long as you just treat all radicals as a fraction exponent, it's not bad, and you can get through it. And so now you've seen a lot of different examples of stuff with exponents. Is there any questions on any of this that you want me to go over real quick? Or you wanted to call it a day and go on with life?